This is mathheals.com, where you can find more links to math and computer science YouTube videos. And let's take a look at relations. Yeah, let's look at our first example. We'll talk about what some of these things mean. Okay. We got the points 2, 3, 4, 5, 8, 1, and 9, 2. Now it says write each relation as a map. This is a relation. It ties certain x values to certain y values. And we call them points. But again, you could have anything here besides the numbers. Now, it says write each relation as a map. What a map is, let me show you by an example. I'm going to put my x values in one column and y values in another column. Now I'm going to write down my x values from smallest to largest, not repeating any. So I got 2, 4, 8, and 9. And I'm going to go ahead and circle these. There's different ways of doing maps. And then I'm going to write down my y values from smallest to largest, not repeating any. So I got 1, 2, 3, 5. And again, I'll circle them. Now we want to graphically show the mapping here. So this maps 2 to 3, so I'll draw a line between them. This one maps 4 to 5, so I'll draw a line between them. This one maps 8 to 1, so I'll draw a line between them. And this one maps 9 to 2, so I'll draw a line between them. Now the second thing they're asking for is a domain. And your domain is basically your x values when we're talking about points. But realize you can have anything here. You can have names, Mary and David, Sally and Frank, type of deal. So it doesn't have to be specifically just like always x values. Typically in math, that's what we see though. And I'm going to write down from smallest to largest, not repeating any. So you just write down these values. So I got 2, 4, 8, and 9. And I put the little curly brackets on it to indicate the set. Now, last thing they're asking for is the range, and this is going to be our y values. Well, our y values are just listed right here. So I got 1, 2, 3, and 5. Let's look at our second problem. 1, 2. Negative 1, negative 2, 3, 2, and 5, 1. And again, I want to do my map, so I'm going to write down my x values from smallest to largest. It's like negative 1's my smallest, then 1, and then 3, and then 5. Now our y values from smallest to largest. Looks like I got a negative 2, 1, and 2. Okay, 1 to 2, so that maps those. Negative 1, negative 2, so maps those. 3 to 2, so maps those. 5 to 1, so maps those. So that'd be my mapping. Now our domain is going to be our x values, which is negative 1, 1, 3, and 5. And our range is going to be our y values, which would be negative 2, 1, and 2. And those will be your answers. Now, the third one gives us our picture, and then says identify domain and range of the graph of the relation from the graph. Let's talk a little bit more about what domain means when you talk about the graph. Domain is our x values where our graph exists. So a domain is x values where a graph exists. So if we look at this problem, if I come over here, this is -3 right here. If I go up or down looking for my graph, I don't see it anywhere. So it doesn't exist at x equals -3. It actually doesn't start existing until -2. Then if I come over here to +3 and go up or down, I don't find my graph anywhere. The rightmost part where it exists is right here, so if I go straight down to there, that tells me 2. So x values, it exists from -2 to 2. So we're going to have -2 to 2, and I'll put brackets around them like that. Later on, we'll talk about when are they not brackets. Now our range, and you can probably guess what this is. This is your y values, where our graph exists. So I'm looking at the y-axis. I come down here, -2. If I go left to right, I don't find my graph anywhere. Actually, -1 is the lowest y value where it exists, because this is the lowest point of my graph. So if I come down or go over, that's -1. This is the highest point in our graph, so if I go over, I see it's 3. So our y value, in terms of our y values, our graph exists from -1 to 3. So that'd be your answer. Let's take a look at another one of those. And again, instructions are to find domain and range. Domain is our x values where our graph exists. X values, you look at your leftmost and rightmost part of your graph. Here's my leftmost part of my graph, and if I go straight up from there, I see it's 1. And my rightmost, if I go straight up from there, I see it's 3. Now they also give you the points right here, so you can easily see that. So domain, this is going to go from 1 to 3. Brackets on them. Now range. Range deals with the lowest point and highest point. Well, this is the lowest point of my graph, and this is the highest point of my graph. If I come over to here, its lowest point is -5, and if I come over to here, my highest point is -3. So it's going to go from -5 to -3. Brackets on them. Now our fifth example. Our x values. Our leftmost part of our graph is right here, which if I went straight down to the x-axis, that'd be x equals 1. Now this seems to stop right here, but whenever you have your graph go off the edge like that, the implication is that it keeps going forever. So this is going forever. So if I come over here to like x equals 4, well, it exists there. If I go up, I can find my graph. If I come up to x equals 5, I can find my graph. If I come over here to x equals 50, if I go up far enough, I'm going to find my graph. Actually, since this keeps going forever this direction, it's going to be all the x values going that way. So this is going to be from 1 to positive infinity. Bracket on that. Now, infinity is a large number we can never reach. You think, what's the largest number? Well, 1 trillion? No. 1 trillion plus 1 is larger. 1 trillion plus 2 is larger. So you can keep adding 1 onto it. So we can never reach it, so infinities always have parentheses. Now, infinity is supposed to be written like an 8 sideways, but I can't do 8 sideways, so I just do 2 O's next to each other. Now, our range. We're looking for our lowest point and our highest point. Well, this is obviously our lowest point right here. If I come over, it's 2. And this is going up like this. In terms of my y values, it's slowly going up. It keeps slowly going up forever. So it's going to positive infinity. So it's going from 2 to positive infinity. And again, bracket on 2 and parentheses on the infinity there. Pretty sure I got these. I probably don't even need to save this page. I think I could probably do all of these on this, to be honest. Next one tells us to use a graph to determine the domain and range. So let's graph this and see what it looks like. So I'm press my y equals. I'm press clear. And now it's -5x minus 3. If your dash is at the very beginning of your problem, it's a negative. If it's between two things, it's a minus. So I'm going to have negative, that's on the bottom row here, 5x minus 3, and then graph. Now if your graph doesn't look like this, press your y equals. Make sure plot 1, plot 2, and plot 3 are not highlighted. If they are, do your up arrow key, put your flashing cursor on whichever one's highlighted, using your right arrow key if necessary, and then press enter one time, and then do a down arrow. And if those are okay, then try press zoom, and then press 6 for Z standard. And then hopefully your graph will look like that. Okay, X values. Well, see how this is going off the screen? So the implication is it keeps going forever. If I come over here to x equals -2, if I go up, I find my graph. If I were to come over to -10 over here, if I were to go up far enough, I would find my graph, because this is slowly going to the left. It'll keep slowly going to the left. And this, as it's going down, is keeps slowly going to the right. So eventually it's going to encompass all my values. So -infinity, +infinity. So for the domain on this one, we'll have -infinity, +infinity. Now our range, our y values. Well, this is going down forever, which means it'll go to -infinity in terms of my y-axis. And this is going up forever, which implies it'll go to +infinity on my y-axis. So my range will be -infinity to +infinity. Now this one, let's take a look at this. I want to graph it first. Y is equal to x squared plus 3. So I'm going to press my y equals, press clear, do my x key, press the x squared plus 3, and then graph. Okay, x values. This is going up, going off the screen, so it's going forever. It's slowly going to the left, so it's going to keep slowly going to the left, keep slowly going to the left forever, so it's going to go to -infinity. In terms of my x values over on this side, it's slowly going to the right, so it'll keep slowly going to the right, so it'll eventually encompass all my x values over here. Because if I went over here to x equals 10, for example, if I go up far enough, I'm going to find my graph. Again, the domain is where your x values, where your graph exists. So this is going to be, for our domain, -infinity to +infinity. Now our range, our y values. If I come down here to y is equal to 1, if I go left to right, I don't find my graph anywhere. The lowest y value where my graph exists looks like is 3. My eyes are showing that right. Which means this is going to start at 3, and then it goes up forever. And I don't know if I can show a big picture of that or not. Let me see. View. I guess not. Oh, there's a large screen. There. That's what I want to show. Because I know on YouTube this may be kind of small. So you see the lowest point is 3, and then it goes up forever. So from 3 to infinity is what the range of this will be. Infinities you never have brackets on, and then this will have a bracket by default. Let's take a look at number 8. Y is equal to negative absolute value of x minus 3. Now, since this little dash here is the very beginning of my problem, it's a negative. And since this is between two things, it's a minus. So let's go graph this. Okay, so I'm going to press my y equals, press my clear, do my negative key. I'll press math, right arrow to num, enter on ABS, do my x key, closing parentheses, minus 3. And then press my graph button. And this is what our graph will look like. Well, as I see, as it's going down like this, keeps going down forever. It's going to the left. And it keeps going to the left forever, so that's -infinity. And in terms of my x values on the right side here, it keeps going down like this, so it's going to go to +infinity. So my domain is going to be -infinity to +infinity. Now for my range. If I come up here to y equals 5, somewhere up here, if I go left to right, I don't find my graph anywhere. It doesn't go up that high, does it? Our highest place it goes, looks like, is -3, and then it goes down forever. Like if I come down here to y equals -20, if I go left to right, I'm going to find my graph somewhere. So, this is going to go from -infinity and is negative 3. Bracket on negative 3. The only time you put a parentheses on the number is if you got an open dot, which you shouldn't have in this section at all. Now here we got y is equal to x to the third plus 1. So let's go graph this. So press my y equals, press my clear, x key, caret 3 plus 1, and then I'll press graph. And let me switch to the large screen here. In terms of my x values, if I come to x equals negative 2, I can go down and find my graph. If I come over here to x equals negative 10, if I go down far enough, I'm going to find my graph. But see how this is going down? It's slowly inching to the left. It'll keep slowly inching to the left, keep slowly inching to the left forever until it goes negative infinity. This one, see how it's slowly inching to the right? It'll keep slowly inching to the right, keep going to the right until it goes to positive infinity. So for x equals negative 10, if I come over here, I'll find my graph if I go down far enough. For x equals positive 10, I'll find my graph if I go down up far enough. So our domain is going to be negative infinity to positive infinity. Now the range is a lot easier to see on this one, because this is pretty well going straight down. So it's obviously going to keep going straight down to negative infinity, and this is almost going straight up, so it'll keep going up to positive infinity. So our range is going to be negative infinity to positive infinity. And I believe that was the last problem. Yes, so let me save this.